Hello students, now in this session of video we are going to discuss class 12th maths and the chapter 1 relation and function. Today in this session of video we are going to discuss some example related to the type of function one and onto function, and now we have two questions over here. First, prove that the greatest integer function from real number to real number. It means the domain is real number and the codomain is real number given by fx is equal to mod of x is neither 1 nor onto. Clear? So we have already discussed this greatest integer function. If you don't know about that, what kind of function is this, you can see my previous video, then you will clear about that, the greatest integer function. Clear? Now what we have to prove, we have to check it is neither 1 nor onto. First I will check for 1. Clear? So we are selecting two elements x1 and x2 or the set of real number codomain. Clear? Okay, for your clarification I will make two sets over here. In these two sets containing the set of real number, so 0, -1, -1.1, -1.2, -2, -2.1 and so on. Similarly 1, 1.1, 1.2, 2, 2.1, 2.3, 3 and so on. Similarly in this side also I am letting that set A and set B both are real number set. So in this also what we have, -0, -1, -1.1, -1.2, -2, -2.1, -2.2, 1, 1.1, 1.2, 2, 2.1, 2.2, 2.3. Oh, okay. Why I am reading this kind of two sets? Because I want just clear your concept about the real number set. So real number is containing what? The real number is containing negative integers, negative decimals, 0, 1, positive integers, positive decimals. Clear? So what we have to prove? We have to prove that the given function is not 1. So we have to select two elements. So let x1 is equal to, I am selecting from this 1.1 and x2 I select 1.2. Clear? So according to the question what we have given, fx1 is equal to the greatest integer function x1 is equal to, now put up the value of x1 is equal to 1.1 and you know that the result is 1. Clear? Due to the greatest integer function we will select the greatest integer from this. fx2 is equal to what? x2 and again 1.2. So what result you get? 1. Okay, total overall what? fx1 is equal to fx2, but just look at that. What is x1? 1.1. What is x2? 1.2. But x1 is not equals to what? x2. So we can say that what? F is not 1, 1. Clear? F is not 1, 1. Clear? Now we go for the onto function. For onto, we have to select an element y. Y belongs to R. R is a set of real number and the element is selecting from codomain. Codomain means B set. Clear? We know that y is equal to fx is equal to the integers of x, and let I will select y from this any decimal number. So y I am selecting 1.2 or 1.3, 1.2, whatever you want to select. So y is equal to 1.2. So modulus greatest integer is equal to y. Further, greatest integer is equal to 1.2. Okay, so there is a problem. The problem is that we cannot get a decimal answer for greatest integer function. So it means it is not possible. We can say it is impossible. Clear? So it means it is impossible. So we can say that what happened? For just look at that. When you are putting the value of 1.1, what you get? 1. When you put 1, so you get 1. 1.2, you get what? 1. Clear? So according to this, for every decimal number you get an integer. Clear? Now we never get an answer of 1.1. Every decimal number, every integer, what we are getting? We are getting always a integer. Clear? So if we are getting every time integer, so it means the decimal number does not have their pre-image. 1.1 does not have their pre-image. 1.2 does not have their pre-image. We can conclude that the every decimal number in set B does not have their pre-image. So the decimal in set R what? R is codomain. Codomain, there is no pre-image of these numbers, these decimal numbers. Hence F is not onto. Why it is not onto? Because every decimal number does not have their pre-image. Clear? Okay, now we move for the next question. Show that a modulus function fx, real number to real number again. So I already, when we are explaining, we are reading the question, it is very careful to see the domain and codomain of the function. So in this case we have domain real number and codomain is also real number. Is given by fx is equal to modulus of x is neither one or non-onto. Clear? So what we have to prove? We have a modulus function given. We also know a modulus function. We are getting always a positive value for this. Clear? Again, solution. And what we have to prove? We have to prove again it is not neither one nor onto. Clear? So let again two element x1 and x2 belongs to real number, domain. Clear? So what? Let again x1 is equal to, I am again explaining that with an figure. So we have a real numbers. So again 0, minus 1, 1, minus 1.1, minus 1.2, 1, 1.1, 1.2, 2, 2.1, so on. Again 0, minus 1, minus 1.1, minus 1.2, minus 2 and so on. 1.1, 1, 1.1, 1.2, 2, 2.1, 2.3. Clear? So x1, what we have to select x1 from this set A, and the result we get in set B. So x1 I can select 1 and x2 I will select minus 1. Clear? So just look at that again. fx1 is equal to fx2 is equal to, sorry, fx1 is equal to modulus of x1 is equal to 1. You played inside of a modulus, so you get what? 1. Similarly, fx2 is equal to modulus of x2 is equal to minus 1. So you get again 1. So overall what? fx1 is equal to what? fx2, because fx1 is equal to 1, fx2 is equal to 1. But x1 is not equals to x2. Clear? Okay, now for onto. So, sorry, we can conclude that f is not 1, 1. Clear? For onto. Okay, for onto, we have to select one element. So, I will select y. Y is belongs to what? The set of real number, or we can say codomain. Y is equal to fx is equal to what? Modulus of x. Again, y can we select any minus 1, suppose that. Let y is equal to minus 1. Clear? So y is equal to what? There exists modulus of y is equal to y, modulus of x is equal to y, and mod of x is equal to minus 1. So it is possible? No. It is also, it is impossible. If it is impossible, so what it means? It means for every negative value in codomain, there is no pre-image. Clear? What? We are putting positive value, we will get positive. Clear? If we are putting negative value, what we are getting? Again positive. So what? The negative real numbers are left. So there is no pre-image for negative real numbers. Clear? So this is not possible. We can conclude that it means for every positive real number, there is no pre-image. There is no pre-image in domain. Clear? For it means that for every real number, positive real number, for every negative real number, for every negative real number, there is no pre-image in domain. Hence, we can say what? F is not on. Clear? So language, according to you, you can change the language, but the conclusion is that for every negative real number, there is no pre-image. These all are containing some pre-image. You are putting the value of negative minus 1, so you will get 1. Minus 1.1, you will get 1. So you will getting a positive real numbers, positive values. But for negative real numbers, there is no pre-image. It means we can say it is not onto. Clear? So this is end up for today. Thank you.